Thank you, Werner. Good morning, everyone. This is a typical screen that you see when you log into Netflix Now. You might see a trending now row, a popular on Netflix row, and a continue watching row. And if you're like me, your continue watching row probably contains Stranger Things Season 2. So let's take a look at this continue watching row. Say, for example, that we weren't able to load what you had been watching previously. That's a part of our system. And so that failing probably shouldn't result in an error. It should result in a fallback. Maybe a fallback that we just don't show you that anymore. Or maybe a fallback that we show you something else instead. What shouldn't happen is that service failing shouldn't result in a streaming error. And so we exercise these fallbacks like this one pretty regularly through chaos experiments at Netflix. Now you may be thinking, couldn't I just beef up my known forms of testing and get that out of the box? Do I need to do chaos experiments as well? So let's talk about some of those known forms of testing. So one of them is a unit test. And a unit test is where we take a single component, we look at the input, and we make sure the output is OK. Given input X, I expect Y to happen. But we're testing a known here. We're testing things that we expect to test and we think to test. And another form of known testing is integration tests. Now, integration tests are also testing knowns as well, except we do it between components. Given input X, I expect component A to output Y, and then I expect component B to output Z. We can also do it on a service level, too. Components in services talking to other services and knowing our expectations from there. Now that we've described some known forms of testing, let's talk about chaos experiments. So you'll notice they look a lot like integration tests, except here, service C to service D, we have the option to either add a failure or add latency by adding time in between our calls. Two troubles that trouble our distributed systems pretty regularly. And so you'll notice here that we dropped the word testing and that we're calling it experiments instead. And that's because here we have unknowns, right? We assume that we're resilient to these failures. We assume that we will be fine, we will provide our fallbacks. And so here it's resulting in unknowns if we're failing these calls or if we're making them latent. So now that we've defined chaos experiments and we've talked about known forms of testing, what's the discipline of chaos engineering as a whole? The discipline of chaos engineering is experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. So chaos engineering is not meant to replace unit and integration tests. They're meant to work together in harmony to give you the most availability possible in order to ensure that your customers have a great experience and that your business stays up and running. In my role as a senior chaos engineer at Netflix, it's my job to expose the chaos in our systems before it renders your home screen unusable and before it renders you unable to watch Stranger Things. Most recently, I've had the opportunity to work on the chaos engineering book with my colleagues at Netflix, Casey, Aaron, Lauren, and Ollie. And we talk about how we perform chaos at Netflix scale, but we also talk about how you can apply it to other types of businesses as well, to early stage startups, to companies of the scale of Netflix, and to different types of industries as well. I've had the opportunity to do chaos at startups and do chaos at Netflix scale. And I want to talk to you about some of my experiences introducing it at a startup. So I worked at an e-commerce startup, and in my second week of work, we had an issue that caused the site to go down for an entire day over a weekend period. And we realized we could have caught this. We could have caught this through regular chaos experiments. So we decided to start introducing chaos. And we did this in the form of graceful restarts and degradation. Now, a lot of you may know of this as Chaos Monkey. And if you're running in the cloud, you should definitely be resilient to a single node or single instance failure. So what happened when we did this graceful restarts and degradation was that our system was already chaotic. We didn't totally evangelize this properly. We ended up bringing QA down for a week. Now, luckily, we had enough foresight not to do this in production yet, but we found issues that were inherent and that would have happened in production anyway if we hadn't done this. And so we started with an opt-out model, but then we moved to an opt-in model, right? And so we worked with teams, we worked with non-critical services that wanted to participate in chaos experiments, that were ready, that had a good steady state defined. And so we moved into targeted chaos. And at that point, the startup was trying to do regional failovers. And so we were heavily reliant on Kafka during these regional failovers. So we decided to start chaos testing Kafka. And we tried to think of ways Kafka could fail in these regional failovers. So we added experiments in the form of maybe changing the offsets, maybe partially deleting a topic or fully deleting a topic, maybe adding a bunch of consumers onto one topic. We had a bunch of different chaos experiments running, and we realized we weren't resilient to all these failure modes. And we were able to find that out before we did these failovers and before we brought these failures with us to other regions. So next in the startup, we were getting momentum, and we tried to move on to cascading failure. And so a cascading failure is when a failure in one part of the system triggers a failure in another part of the system, which triggers successive failures. So we tried to cause a cascading failure. A bunch of service teams and I got in a room together, and we had monitors up on the screen, and we triggered a failure. And we did cause a cascading failure, but we did not cause the one that we intended. What ended up happening was search stopped receiving timeouts, pricing wasn't handling that, and then Elasticsearch went completely down in QA. And again, we were still doing this in QA. But it was things that we would have seen in production had we not been chaos experimenting yet. And that was when I really saw momentum get up in that startup, and I actually saw a culture change. I saw a culture change from people not asking what happens if this fails to people asking what happens when this fails. And when I moved to Netflix, I was lucky enough that this was already the culture. Netflix is doing things differently, and they were doing it through failure injection testing. So service owners can actually easily add latency or failure. So that screen that we looked at earlier, the chaos experiment screen, we allow service owners to easily add latency or failure based on predefined criteria met and in different injection points and building blocks of our system. But what's important here, we realize, is safety and monitoring. With our failure injection testing framework, we had no way to impact how much traffic that we were affecting. And so we built a chaos automation platform on top of it that allowed us to determine how much traffic that we were impacting. And we called this CHAP. We're working on it actively today. And so the way it works is that calls from service A to service B are behaving as normally. Now, at Netflix, our key business metric is whether or not you can actually press play. Now, maybe you see a screen and you're pressing play and nothing's happening. If that happens, we see a spike in that key business metric. And we call it SPS, stream starts per second. Or maybe the play button isn't even available at all, and in that case, we see a dip in SPS. But we always keep a watchful eye on this key business metric, SPS, when we're doing these chaos experiments. And so we look at our SPS, and then we calculate the smallest fraction of traffic possible in order for us to get a signal that the chaos experiment is working properly. So say, for example, in this experiment, we calculated 2%. 2% of traffic is what we needed to get a signal here. So we take that 2% and we split it in half. We route 1% of it into a control cluster, and then we route the other % of it into an experiment cluster. And in the control cluster, we don't do anything to it. We let it behave as normal because that's our control. And then our experiment cluster, that's where we can add our failure or our latency. And so that SPS, that key business metric that I was talking about earlier, We actively watch this during the experiments through automated canary analysis. And we look at our control graph and we look at our experiment graph, and we see if those deviate too far from each other. And if they do, we automatically short the experiment. And so this is a key safety mechanism in place when we're doing our chaos experiments, because if the experiment shorts because we see an error, we're able to stop the experiment early, and the engineer is able to go offline and debug the issue without being under the fire of a pager going off or a customer seeing an issue. And so we're able to debug this before it renders Netflix unusable for you. So what's the future of this? So right now, in order to do chaos experiments, we had to meet with teams, we had to decide what good injection points were, we had to decide what good failure scenarios were, and it was taking a lot of time. You know, it would take a few hour meetings, and we decided that we needed to start getting smarter about this. Maybe we could come up with an algorithm that decided what the best chaos experiments were. And so that's what we did. We've looked at the entire system as a whole and started coming up with the chaos experiments on our own and automated them. We're automating the criticality of them too. If they're a more critical experiment, we'll run it more often. We know this is something that needs to be run more often. And so we're in the middle of this right now, and it's been going great so far. It allows us to run way more experiments a day. It eliminates the meetings that we had to have before. And we're seeing a lot of issues that we're able to reveal before the customer sees them. So you may be thinking here, I need more chaos in my life. And you totally do. Everyone can and should be doing this. So if you want to learn more, you can go to theprinciplesofchaos.org to hear more about the discipline. The book that I mentioned earlier is also free online on O'Reilly. And if I can leave you with one final truth today, it's that chaos doesn't cause problems. It reveals them. Thank you.